Okay, I'm going to use the same example problems from before. So once you know how to do these, you're going to be good, except for now I'm going to talk about my vertical asymptotes. Vertical asymptotes, what they are, is a value that your graph can never equal. So a value that your graph cannot touch. If you remember the other day when we did inverse variation, an inverse variation function looked like this. If the k value was positive, that means that you have a vertical asymptote, or a value that it can never equal at x equals 0. The graph never crosses this line. So that's called a vertical asymptote. Vertical asymptotes are just values that it can't cross. Your actual graph cannot cross this line. It can't go for it. Okay? So what you're looking for is, what is the value of that line? On this one, it's x equals 0. The way that you find a vertical asymptote is it's whatever makes your denominator equal to 0. So on the example that I did first, on the other one, x squared minus 9 over x squared minus 4, and we found zeros for the numerator at 3 and negative 3. Now we're going to look for zeros on the denominator. So that's why I still factored this out on the other example. The numerator doesn't matter when we're looking for vertical asymptotes. Only the denominator does. So I want to set both of these equal to 0. And then solve. What you're looking for are all of the values that make your denominator equal to 0.
I have a question.
Okay, hang on, let me finish this first, and then I'll answer your question. What's your question?
Okay, so you know the homework the work that everybody did in class yesterday?
Yes.
Did you do the work?
Not for you.
Okay, because I tried to do it and I watched the video and everything, but I was really confused on like the physics, stuff like that.
Just ask questions, that's okay.
Okay, so just wherever?
Okay, so we're still looking for vertical asymptotes. So your vertical asymptotes are still going to be just the denominator. We don't care about the numerator. So I'm going to set this denominator equal to 0 and solve. Remember that it's the equation of a line. So it needs to say x equals something. That's a thing that a lot of you guys don't do, is write it as an equation. So this one only has 1 at x equals negative 3. It's going to be the same on all of these. So these are fairly simple. It's just a matter of factoring it out. This is the other example I did on the other video. My numerator doesn't matter. Only the denominator does. So this gives me x equals negative 1. Vertical asymptote at x equals negative 1. And really that's it on vertical asymptotes.